Welcome back to another devlog. As you can see here, it doesn't seem like very much has changed, but behind the scenes, I feel like a lot of good things have changed. So, what's happened is you might see here this new actor component. And what it does is it has a couple things. So, first, on the event graph, well, let me explain what an actor component is, I should say. So, let's go to the base body here. Here I've added a actor component by literally dragging the actor component into this scene for the subcomponent. So what I've found when it comes to Unreal Engine in general is that child actors, actors that you put inside of a component, like an actor within an actor, they don't end up performing very well at all. And I'm not sure what the reason is, but I've found that most people that I've spoken to regarding child actors for managing encapsulation of concepts and logics, they tend to just be somewhat glitchy to some degree. I ran into that with my movement system and all that. Ended up having to pull things out of that system. It's also why I actually pulled this worm body and its segments out of being child components into the scene itself, because everything seems to work better when I do that. However, I had a need, as I stated in my last video, for repeated code to just be reused between these components, because in every component, I'm going to be animating the material so that you can see how the events are pulsing through the body. So what this is, and I probably need to rename this as something less crazy, but this is a dynamic material animation component that gets added to all the actors. And what it has is its own event graph, which has its own event tick, and I manage it by having a flag to enable the fade effect. And here, what you see here is just like some math, and then I'm also using a curve object, which I'll show you here actually. So I have a couple curves. I went with this one eventually. So all a curve is just this asset that you can create in the miscellaneous section of your adding context menu. You just hit that, you create a new curve. You just define how long the curve is and to what degree the values should change within that curve. So what's going to happen here is that when I get a float value from this curve, I'm going to do some division on the elapsed time, the length of the curve that we're currently at. Elapsed time gets incremented every time we go through the event tick, so that becomes the place on the curve that we want to return. And I divide it by the length of the curve so that we can just adjust how long the animation is, because the curve itself is just 1 second long. So it's able to scale up and down pretty neatly. And then here I just multiply the emissive amount by the float value, and then that changes the scalar value for the emissive amount being applied to the mesh material. And it'll just animate that all the way through. But if we are at a state where we're past the length of the curve, we just go in and reset it, turn off the flag, fire an event to anything that contains this by dispatching it, and then also resetting the color to its original color that it was originally set at. You initialize this by calling init on this actor component, which just you pass in the right values. This used to have more in it, but I was able to simplify it to just create the dynamic material. Dynamic material takes a mesh and a base color. We create a dynamic material instance with that, starting with the inst material of the thing that has the parameters I need. And then we create a mesh material. We save the mesh material that gets generated from that. Then we target the mesh, assign it to that, assign that material to it. Then we set the vector parameter of its color to what we passed in so that it has the same color that we want it to. So now that you've initted, it's all ready to go. If you ever set the flag inside of this component to true, it'll run through its event graph and process the animation. And then when it's done, it'll fire an event so that you know it's done, and then you can do stuff at the end of that. And it has all these values stored within inside of it, so I don't have to care about it on the outside. So if we go to the base body, you'll see that I just have this dynamic material animation. I initialize, I give it a color, a mesh, which is here. And when I press 1, I process the fade out. And then when it's done, I invoke a start brain tick event, which is that global event I mentioned before. So as you can see, I didn't have to do very much here, which, it's not bad for one instance, but now I can just go into the next step, which is when it reaches out to the brain through the event. And as you can see here, when it starts the same way as I did before. I call fade out when this is called. I make sure that the event being passed through is a blood impulse. And the reason why it's a blood impulse is because, reason why I'm passing the event through is because when you look at here, when I create a dynamic material, oh, I'm sorry. That's not what happens. Ah, yes, here's the fade out event. So when fade out is called by a body part or brain or something like that, you pass the event, which is event system event. And here, I'm checking to see if the event is either a nerve impulse or a blood impulse. And if it's a nerve impulse, I change the color of the base color of the material to yellow. And if it's blood, I change it to red because, blood is red. Now, that makes it to where you can visually see what type of impulse is being handled at the time, which makes the actual analysis of the pulses throughout the body much more clear, as we'll see here in a moment. At the end of all of this, we set the enable to true, and then this true flag is constantly being checked at the event graph level, so it's always false until it's set to true. The animation logic, processes. The color switches immediately, but then this emissive value goes up in scalar value, and it makes it look like it glows a little bit, and then it'll fade back out. We turn off the flag, and then we do the end state. So once we get the, on the brain, we get the start brain tick, we fade out. At the end of it, we reach out to the parent actor, like we had before, send a nerve impulse, which is going to be to the body part. The body part then just takes any event and conveys it to the fade out, which at the end invokes it on the proper actor, taking the event pass through to the invoke so that it's always evoking the proper event that we intended at the end of it to its parent actor. Yeah. So we invoke this on its parent actor. My brain is not processing this. Basically, it gets invoked, and after it's invoked, we run. We pass this over, we pass this through. Anyway, the gist of it is that at the end of the animation, we run through all the attached children on this component, which is the body, which contains body parts. We loop through the body parts, and then we invoke the intended event through to all those. And I do a return node just in case it mattered, but I don't think it did. And that's all it does. And the logic will be similar when it comes to the body part connector, except that it invokes it on what we want it to when we pass it in, whatever it's connected to. So again, same process. As you can see, it's a lot cleaner going through. The heart looks almost like the brain, except it just passes a impulse when we receive a nerve impulse of blood. And then after that, the logic is set so that we can modify things as we need, right? So at this point, you should be able to hit play. And we hit a 1, which starts the body tick there. Hits the brain with the blood. Yeah, and as you can see, it's actually a lot clearer what impulses are going through the body now. That last nerve impulse reaches the end, then a blood impulse goes to the connector there, and that gets thrown. So this pattern of parent, children, parent, children, parent, children allows it to continuously propagate. And just to illustrate that some more, let's add another segment, right? So I'm gonna, let's see, we'll go with this guy. I'll just go ahead and paste him. Now we have a segment 4. And he's just gonna be, we'll throw him up here, like so, right? But he needs a connector. So we'll take a connector there, paste it there. And we'll put it on segment 2. Because segment 2 will contain it. So now segment 2 will contain 2 elements. And then we'll just rotate it vertically. And move it just to visually represent. It doesn't actually need to be in the right position. And then when we want to specify what it's connecting to, we want it to connect to segment 4. So we're going to select segment 4. We're going to save, and we're going to see if it works. So yeah, we press 1. Impulse is sent to the heart and the set connector, which goes to the first segment, connector, next segment, 2 connectors, and then the 2 segments. And I didn't have to add more logic to increase the complexity of this creature. And in the future, these signals will affect different body parts, like an eye, for instance, which might affect, a creature's ability to see things or hear things. There might be legs, which if they have the signals, they can walk. If they don't, maybe they can't walk. Stuff like that. So that's my ideal, at least. So yeah, pretty cool. Thanks for watching.